Kia ora and welcome to video 3 in the series Insightful Integration. In this video, we're going to look at a problem that involves a trig identity. So again, just an integral, no applications or anything. In this case, it's a definite integral because we have some limits there, 0 and 2 pi over 3. But we do need a trig identity to be able to do this. In NCEA questions, trig identities are fairly standard. You either have the double angle formula or you have the cos squared plus sine squared formula. And so I encourage you to have a look at your formula sheet, get familiarity with it, and pick an identity here that is going to help us solve this problem. You're given a hint. Okay, you're told to use the substitution t equals tan of theta over 2. It's not very obvious as to how you're going to use that. But anyways, the solution after the intro music. All the best.
Okay, as I said in video 1 of this series, if a trickier substitution is needed, in this case a trig one, then it is usually provided for you. If it's not provided, there's probably something in the question like the diagram, the geometry of the situation that might assist with making a substitution, but this is beyond the scope of a typical NCA problem, and so therefore the hint is provided for us. Whenever we make a substitution, we also differentiate it. So it seems a little bit strange to make tan theta over 2 a substitution because it's not actually in the problem. Like, where is the tan theta over 2 to replace it with t? But let's just go about making the substitution first and differentiating it, and then it might become apparent. So if I differentiate tan of theta over 2, I've got dt equals tan differentiates to sec squared, and then I've got multiplied by a half, chain rule there, and I'm multiplying by theta over 2's derivative, and then d theta. Okay, so does that appear in the question? I can't see it. I can just tidy this up a little bit. A half sec squared. Sec squared is 1 over cosine squared. So if I write this as 1 over 2 cos squared theta over 2. And then it might not be obvious, but actually that's what this is. 1 plus cos theta is equal to 2 cos squared theta over 2. It's the half angle formula for cosine. If we look at the double angle formula for cosine, which is on the formula sheet, we have cos 2a is equal to 2 cos squared a minus 1. And if I rearrange that, I've got cos 2a plus 1 is equal to 2 cos squared a. And then if I want to replace the angle, in this case I want to make the angle half, I can do that, and I just make the angle over here half as well. So I've got cos a plus 1 is equal to 2 cos squared a over 2, and there we go. So it seemed a bit strange to make the substitution tan theta over 2, but in fact the derivative of it was sitting in the problem. So where do we go from here? We've got the integral, we've got to change the limits. We don't have to, but it's nicer to. These dudes here are both theta values. Theta equals 0 and theta equals 2 pi over 3. So if I chuck them into my substitution, when theta equals 0, t is equal to tan of 0 over 2. So tan of 0 is just 0. And when theta equals 2 pi over 3, tan of 2 pi over 3 divided by 2, tan of pi over 3. Tan of pi over 3 is equal to root 3. And you can get that by looking at the special triangle on the formula sheet or your graphics calculator. So we have the integral between 0 and root 3. Looking at the problem, 1 over 1 plus cos theta d theta. Well, that is actually just dt. So we're integrating dt, or 1 with respect to t, which is just t, between root 3 and 0. So the answer is root 3 minus 0, or root 3. So that substitution made the integral so easy, but it wasn't so obvious how to even make the substitution until you differentiated it and noticed that the derivative simplified using a trig identity and meant we could replace the whole integral. Let's get rid of that. The whole integral here was all just dt. The answer being root 3, and we'll catch you in the next video.